Hi there! This radio looks fancy, right? It looks like a radio that you can buy on a store or shop. It has the controls, control wheels, it has frequency numbers on it, it has a speaker, switch for AM FM, telescopic antenna. But this is actually a kit. You can build it by yourself. In the following videos you will see how to build this kit. It's a FM and an AM radio, and it came pretty much like this. Of course I have already opened it because I had to change a few things that I don't want to show on camera. Yeah, here's the housing, and you can see the parts already in the housing falling around. On the back side there is the manual, which I had to change because once again I'm not sure if this is copyright or not, and so I want to show you only a few things. I mean, you can't really do much with this schematic without the values. Below that is the PCB, printed circuit board, and another sticker that you can glue on top, probably here, which shows the frequency or which band you have tuned in. Well, I'll see if I build it. This is like first time opening. I've taken away the plastic foil, and this is what's inside. Here is the FM AM scale, and as you can see, unlike on the other radio that I made, the letters are very well, no problem whatsoever. Here is the speaker. Seems like they have packed it in some kind of Chinese newsletter or newspaper. Here is the circuit board, once again the manual. Here's one side of this case, and here is the other side with some components and the antenna. Okay. These are the components that are inside this radio kit. Electrolytic capacitors, a switch, a telescopic antenna for FM reception, some mechanical components, screws, and these knobs for tuning and volume, and sticker for the tuning knob, a letter where I don't know what that means. This is in the opposite direction. I think this is a 6, so it has to be turned around. Just do it and turn it around. I have no idea what this means, since I can't read Chinese right now. Anyway, here's the PCB, here's the sticker. The cool thing about the sticker is that it's having 2 glue lines on its back side, so I can glue it to this housing, unlike on the blue radio, which doesn't have, or which didn't have, glue on this similar sticker. Here is the loudspeaker that acts quite fancy for the price. Well, this kit did cost. This looks quite fancy, the speaker. Here is the backside from the housing with the battery cover. You can also see the size of the speaker. I'm quite impressed by it. Anyway, here is the manual, some wires that have been pre-soldered and uninsulated and pre-soldered already, on-off switch, volume control, battery connectors, AM antenna with plastic holder, tuning capacitor, and some coils with even the frequency written on the coils. That's neat. Even if the frequency wouldn't have been written on them, it's obvious, because black and red is for AM and blue would be for FM. You know that if you're as much into radios as I am. Here is a coil pre-wound. Here is an orange filter. This one's for AM, and a brown filter. This one's for FM. Here is a LED showing you that the radio is turned on. And here is the main integrated circuit that contains all the radio circuits and the audio amplifier circuit. Okay, well that's what's inside this AM/FM radio kit. Now I'm going to solder in the SMD surface mount device integrated circuit to the circuit board. For soldering in such small components you need special solder tools. While this is still a component that is relatively easy to solder in, you could, with some skill, solder it in with a normal solder iron, like the one I'm using here. This is just a standard solder iron. You can see the relatively thick tip on this solder iron. For the true hole mount components like capacitor, resistor, and so far and so on, this is fine, but it's relatively tricky to mount such a small device as this to the circuit board with this solder iron. So I have this solder iron here, which is a so-called solder needle. The solder needle is very thin, it has a very thin tip, And also I'm using a special solder which is relatively thin, so you can compare it. On the upper side is the normal solder and on the lower side is the small solder. So it's no problem soldering surface mount components with this device. Now I want to show you how to solder in this integrated circuit into the printed circuit board. The most clever thing you want to do is you want to solder in the outer pins first, so there is no mechanical stabilization. I'm going to solder in one of the outer pins right now. It's a little bit hard because I do barely see anything because of the camera. So come on. So you solder in one of the outer pins and then you solder in one of the other pins. You want to make sure that it's fitted properly. So there we go. It's alright. This is a radio nearly finished video. I want to show you how far I am after this soldering in the SMD IC thing. So this is the front of the radio. I have already mounted the speaker with this, if you want to call it like that, claws. If you put them in the other direction, the speaker is very loose and it doesn't hold. So I think they thought you should build it in like this. I've built in the battery holders, the battery connectors, and the first problem appeared. Because this is one of the original length of a wire. I've cut this one because I will do something to fix it. Anyway, the wire from plus to the circuit board is too short, and if I make minus, if I take it out there and put it there, the minus lead to the board is going to be too short. Well, I could solder it to the speaker. I mean, I could solder this minus to the speaker if I would make minus there, and then it's not the way you are doing it, definitely not. Okay, on the other side I've glued in the stickers. It holds okay. I wouldn't say it holds massive, but it does hold. Here is the back side of the radio. I've already mounted the telescopic antenna. It's quite self-explaining what belongs to where. But anyway, here is the antenna where it clips in. You know that's sure from another radio, but it's very hard. I can't even get it out. It's so massive. You have to get it in with a trick. And if you push the antenna together to its minimum length, it doesn't even fit. This thing then is there, so it doesn't fit in. Anyway, here you can see how it's mounted. It's alright, nothing to complain there. But now the big problem. I had massive, and that's really saying it, massive problems with the PCB, with the circuit board. I started building it yesterday. I wanted to build it as the manual says it, not after the schematic. There's like a part list. For example, part number 1, integrated circuit. Part number whatsoever, let's say part number 20, capacitor. Then you can see it's capacitor C21 or so, and it has 100 nanofarad. This is just an example. Then you look on the PCB, oh, where is C21? Ah, there it is, and then you solder it in. But the problem is that this manual and the values, they're all wrong. There's nothing right. And the more I was digging into it, the more mistakes I found. One massive mistake. For example, this is the on-off switch. And here you can see this GB plus thingy. Well, they want you to solder in the battery connector there, because it makes sense. Because if you have a look at the PCB, you will see that this battery connector goes over this switch to the rest of the circuit board, but it goes over the switch. Well, if you follow the trace, you will see that there is plus, then there is a switch, and there's what? There is ground. So when you switch it on, you have a neat short circuit. This is just one small mistake they made. I will have to fix that with my Dremel tool. And another thing that I noticed is that there is another GB plus between the capacitors. You may be able to see it. Now it's focused, GB plus, and that's the GB plus that actually goes to the integrated circuit and helps to power the complete unit. Okay, so I've built everything in. There's just one capacitor left, as you can see, but I'll get to that in a couple of minutes or seconds. We'll see. You can see that over this blue capacitor, which I had to supply by myself, by the way, as I had to supply this brown capacitor, there's one capacitor left. The interesting thing is there are some capacitors left over. They want you to build in 220 microfarad electrolytic capacitors for coupling the speaker, for buffering the supply voltage whatsoever. But there are no such capacitors supplied. But therefore, as a prize present, you get this 0.47 microfarad capacitor, which is nowhere needed in the circuit. I checked the manual, I checked this stuff, and it's nowhere listed. This is just like a present. You get some 10 capacitor, and what's that? Let's say it's 18 picofarads, but you don't need these capacitors anywhere in the manual, anywhere in the schematic. So you have to bring your own capacitors to get it working as the manual wants you to work it, or wants you to get it working. According to the manual or to the parts list, both ceramic filters are in the wrong direction. So CF2 should be where the orange filter is, and the orange filter should be where the brown filter is. But if you dig into it, and if you do it as I'm doing it, oh, I see something right now. At least, as you can see, 28, at least they got the numbers right. But anyway, if you dig into it, you will find out that it doesn't make sense to have this AM-IF coil feeding its output signal into a 10.7 MHz filter if you follow the layout and if you have to do some thinking about it. Many huge mistakes. You definitely cannot bring this kit to a beginner, expect him to build it and then it works. It doesn't work. For example, C15, if you follow the instructions, and you can't see it on camera, I'm sorry, it's really hard to film, because this is also a capacitor I had to add from myself because it wasn't supplied. Anyway, this capacitor here, this over the big electrolytic, you can see this brown ceramic capacitor. According to the printed circuit board, there should be an electrolytic capacitor, but according to the manual, there should be a ceramic capacitor. Well, I know which one is right, but mistakes over mistakes. This big coil here, the upper one that has the bigger diameter, this one, isn't even listed. Also, they say there is a third ceramic filter on the manual. On the schematic, the probably FM detector, phase shift thingy, whatsoever, they made it with a third ceramic filter and a resistor. They say that there are 3 transformers supplied with this kit, and there are 3, 1, 2 and 3, but this circuit, as they have built it on the board, is nowhere in the manual. So well, I think you get what I want to tell you. I really don't know what's wrong with this kit. I'm sure maybe they changed the design. For example, this is the manual for a new, maybe a little bit better kit or a little bit worse. I don't know which one is new. Either the circuit board is like the new version and the manual is the old version, or the manual is the new version and the circuit board is the old version, but both don't mix up very well. So I built it just as I read the manual. I read the circuit board. The schematic. I read the schematic and built it according to the schematic. I had to solder out capacitors, had to resolder capacitors on different spots, and so far and so on. And I made a test off camera. I connected the speaker and connected as they wanted it with a current limit. I connected my power supply there and connected there, switched on, and hey, there was a short circuit. So I connected my power supply to this GB Plus thingy, and I could hear static from the speaker. It was set to AM, and it seems like in this configuration the AM band seems to work. That's what I want to say, it seems to work. I can pick up various interference signals, since there are at this time no more German radio stations at the day where I live. I could pick up static on the AM band. The AM band seems to work fine, and I switched over to FM. I could hear FM static, and after tuning the capacitor I could, even without antenna, already pick up quite some stations. But it didn't work. And yeah, I mean, it sounded like there was static, but if you tune to a station, the static will only get quiet and you won't hear music, like it's receiving AM actually. And that's because there's no capacitor yet soldered in between this discriminator output and this tuning coil, wherewith you probably align the phase shift for the FM detector or the FM demodulator. So yeah. And keep in mind, it's working, but it's working because according to the schematic, according to the manual's parts list, I have made huge mistakes. But with my huge mistakes, it's actually working. I think you wouldn't even get out a tone, or maybe it's motorboating or whatever, if you build it just as they want you to build it. So, yeah.